This video was brought to you by me. I decided I wanted to make a video, so I did. So if you look at the Earth from above, straight down at the North Pole, and if you looked at all of the time zones, it might look something like this, with each time zone radiating out like a slice of pie. As you go counterclockwise around the circle, it would get later and later in the day, from 9 p.m. to 10 p.m. to 11 p.m., etc. But what happens when you hit midnight? What if in this time zone it's 11:30 p.m. and this one it's 12:30 a.m.? Here, it's not just the time of day that changes, the day itself also changes. If it's 11:30 p.m. on a Wednesday here, it'll be 12:30 a.m. on a Thursday here, and then 1:30 a.m. Thursday, 2:30 a.m. Thursday, etc. But then you go all the way around doing that, and eventually you get back here and you label this as 1:30 p.m. Thursday. But we already know that it's 11:30 p.m. Wednesday here, not Thursday. What went wrong? We know that over here it's Wednesday, and over here it's Thursday, which means at some point in here, we have to jump from being in Thursday to being back in Wednesday. So where do we do that? The answer is the International Dateline. Right about here in the middle of the Pacific, it'll go 1:30 p.m. Thursday, 2:30 p.m. Thursday, 3:30 p.m. Wednesday, 4:30 p.m. Wednesday, etc. This means that at any given time, the globe will look kind of like a pie chart with some of the planet in one day and some of it in the next day. And there will be two lines between the days. One of those lines will be wherever in the world it's around midnight at that moment, and the other will be the International Dateline in the Pacific. And that means that once a day, when it's midnight right where the International Dateline is, the two lines will line up and the whole planet will be on the same day, right? Wrong, because time zones of the Pacific don't look like this, they look like this. And Okay, let me explain what these labels are real quick. These numbers are just the time zone's UTC offset, and that's basically just how different it is from what time it is in London. So if it's 1 p.m. in London, then it's 1 a.m. in the -12 offset, and it'll also be 1 a.m. in the +12 offset. So does that mean that these time zones are the same? Nope, because we're not just looking at what time it is, we're looking at what day it is. So if it's 1 p.m. on a Wednesday in London, then 12 hours before that is 1 a.m. that same Wednesday, so that's what time it is in the -12 time zone. But 12 hours after 1 p.m. Wednesday is 1 a.m. Thursday, so that's what time it is in the +12 time zone. And, looking at this map, you may note that the time zones do not range from -12 to +12. They range from -12 to +14. According to this video by Jay Foreman, this is because Kiribati wanted to be on the same side of the International Dateline as its trading partner, Australia, but I didn't fact-check that because that would require doing actual research, and I forgot how to read sometime in 2018. But I don't care why time zones are like this. My question is, how could you exploit this to do something ridiculous? And the answer to that is pretty straightforward, because right over here, between the Line Islands and Jarvis Island, is a time zone border that is also on the International Dateline, and together they create a 25-hour jump. So if you're over here, and it's Sunday evening, and you really don't want it to be Monday tomorrow, just hop across the time zone and you've jumped back to Saturday evening. Then, the next day, if you time it just right, by going back across the border at 11:30 p.m. Sunday evening, you'll wind up back in Kiribati at 12:30 a.m. Tuesday morning, having skipped Monday entirely. Repeat the process every weekend for a 4-day work week. So yeah, I'll see you guys in my next video, which I might never make, because obsessing over my YouTube channel was kinda bad for my brain, and I've decided I need to focus on building other sources of meaning and fulfillment in my life. Goodbye.